All right, guys. So just check if we are live and if I'm audible or not, and then we'll be starting with the session. Okay. Just let me know if my audio and video is proper, guys. I'm sorry. Yeah. So I hope that you can see me properly, you can hear me properly. If there is anything which is not proper, do let me know, okay? So hi, hello, good evening, my dear students. This is Ritika, your chemistry educator, back at Unacademy, and bringing with me a very, very important session for grade 9. So this session is going to be very important because we are going to discuss numericals of one of the gas law. And the law that we are going to discuss today, it is Boyle's law. Now, before we move further, let's know a bit about myself. Uh, Rox Sagar. Hi, hello. Are you fine? Chaliye. So, guys, you can join us on the Telegram channel, okay, to receive the notes, to receive the homework, and all the important updates of the things that are going on here at Unacademy. Also, you can join my Telegram channel to receive the questions and important notes. Okay, I'm very fine. Thank you so much. So, guys, let us know first of all what the chapter, the gas laws, is all about. This chapter, it is about the laws which govern the behavior of the gases, okay? And in this chapter there are two main laws, which is Boyle's law, and the second one is Charles' law. Okay, the third one is the gas equation, which is a combination of Boyle's and Charles' law. Okay, so today we are going to focus on this thing, that is the Boyle's law. Okay, we will be understanding its statement, the conditions, and of course we will be solving some of the numericals. Okay, so before that, the important things I hope everyone knows, that conversion of temperature, which is a bit necessary when we go for numericals, Kelvin to degrees Celsius, and just the opposite. Okay, so whenever we are given the temperature in degrees Celsius and we are expected it to convert it into Kelvin, what are we supposed to do? Just add 273, which means 0 degrees Celsius. If the temperature is given, then it means 0 plus 273, which is equal to 273 Kelvin. This is just the basic, and just opposite for the Celsius to Kelvin to Celsius. Okay, subtract it. Now let us get started with the Boyle's law quickly. So guys, there was a scientist, there was a person named Robert Boyle. Okay, and what did he do? He tried to study the relationship between pressure and volume of the gas. Okay, तो उन्होंने क्या किया? He just tried to see that what happens to the pressure and volume of the gas if temperature is kept constant. Okay, and what did he find out? He found that if we are keeping the temperature as the constant quantity, तो अगर हमने लेट सपोज किसी भी गैस का ना एक फिक्स्ड वॉल्यूम ले रखा है, फिक्स्ड मास ले रखा है, ओके, नॉट वॉल्यूम एग्जैक्टली, सो अगर हम लोगों ने किसी भी गैस का एक फिक्स्ड मास ले रखा है, तो उसका जो वॉल्यूम है इट वुड जस्ट डिक्रीज टू हाफ व्हेन वी डबल द प्रेशर. मतलब अगर हमने प्रेशर को डबल कर दिया है, तो वॉल्यूम क्या हो जाएगा? It would just become half. Okay, so this was the relationship that he derived between pressure and volume, keeping the temperature as a constant quantity. Okay, सबसे important है to mention here that T is a constant quantity. Okay, now let us try to see how to derive a mathematical expression for the same. Now, let us suppose we are taking a gas, okay, which is occupying volume V1 at pressure P1. ओके, तो अभी हम लोगों ने क्या देखा था दैट अगर प्रेशर डबल है तो वॉल्यूम हाफ हो रहा है, मतलब कि दोनों के बीच में एक इनवर्स रिलेशन एस्टैब्लिश हो रहा है. सो व्हाट वी कैन राइट, V1 इट इज इनवर्सली प्रोपोर्शनल टू P1. Okay, now guys, if I remove this proportionality sign, hello Ishan, how are you? Good evening dear. Ma'am, our first topic is behavior and characteristic property of gases that we have already covered, beta. Okay, if you have missed out on the sessions, you can just see the previous videos, okay? So if I remove this proportionality sign, what I would get equal to with a constant K upon P1. And do not forget to mention Rk is a constant quantity here. Now guys, let us suppose that this volume and pressure is changing. How? So if V2 is volume occupied at pressure P2, then what we can write? We can write V2 is inversely proportional to P2. Again, V2 is equal to K upon P2, where K is a constant. Okay, so from this equation number 1 and 2, what we can write? See, from this equation I can write V1 P1 is equal to K, and from this one I can write V2 P2 is equal to K. Okay, so when I equalize both these equations, what I would be getting is P1 V1 is equal to P2 V2 is equal to constant, and the condition is at constant temperature. Got it guys? So this is the mathematical expression of the Boyle's law, and this equation, it is known as Boyle's law equation. Got it guys? Just let me know with a thumbs up, yes, no, if you have understood this equation, so that we can move towards the numericals of this particular law. So I guess this is a very easy law, and the equation is also easy. Yeah. Okay. Now here, what are the constant quantities? So normally what do we think is, okay, temperature is the constant quantity, but with the temperature guys, there is one more constant quantity जो कि हम लोग ना कभी कभी भूल जाते हैं, that mass. Okay, जो हम लोगों ने mass लिया है किसी गैस का, वो भी constant ही रहेगा. Then only this law will be applicable. Okay, so mass and temperature are the two constant quantities in the Boyle's law. Can we move towards solving numericals now? Let's go with the numerical or two to understand this law better. Okay, so I'll be writing the question, and if you guys can solve it, please do let me know. The question is, a gas occupies 800 centimeter cube under 760 millimeter of mercury pressure. Find under what pressure the gas will occupy 380 centimeter cube, the temperature remaining constant. So let's solve this question, guys. Now, what are the values which are given to us? First of all, what is the volume 1 given to us? Can anyone tell me what would be V1? The value of V1 is? Anyone? What would be the value of volume 1? Correct. It is 800 centimeter cube. Now, next P1. What is the value of P1? हाँ जी बच्चे लोगों, what is the value of P1? It's 760 millimeter of mercury. And what is the next value given? P2, which is 380 centimeter cube. है ना? Now what do we have to calculate? We have to calculate pressure 2. अभी यहाँ temperature constant है, which means we will be applying the Boyle's law. Okay, and what would be the equation? P1 V1 is equal to P2 V2. Putting the values in the equation, it is 760 into 800 equals to P2 we have to find out into 380. Sorry. So transferring the values, 760 into 800 upon 380 would be the final equation. So can anyone tell me the value of P2 by solving this? What would be the value of P2? Hello Veer, hi. हाँ जी बच्चे लोगों, what is the answer? The value of P2 is no one. It's just a basic math, guys. So when you solve it, yeah, correct, the D gaming 1600 mm of mercury. So that is the correct answer. Okay, the value of pressure 2 is, from which book are you teaching? I follow Selena, which is I guess the standard book, which is given by ICSE. Although there are many books, okay, I'm not promoting any book, but yeah, right now I'm following Selena. चलिए, moving on to next question. Okay, this question is clear to everyone, right? कोई confusion इस question में? किसी को? Come on, guys. चलो, बढ़ते हैं next question की तरफ. So, guys, your next question says, a gas occupies 600 centimeter cube under a pressure of 700 millimeter of mercury. Under what pressure the volume of gas would reduce by? Okay, so this is not a direct question. Okay, इसमें थोड़ी सी extra math लगानी पड़ेगी हमें. 20% of its original volume temperature being constant. Now guys, let's see what are the values given to us first of all. तो क्या दे रखा है हमें? What are the values given to us? P1, V1, P2, V2 जो भी दे रखा है, let me know. 600 centimeter cube. Okay, so this is our V1. Next is P1, which is given to us as 700 millimeter of mercury. Okay, now these two values are directly given to us, but we have to find P2, of course, which is unknown. That is okay. But जो V2 है, we have not been given the volume directly. It is told that it is reduced by 20%. So we have to first of all calculate 20% of original volume, which is 20% of V1. What would be the value of V2? No, it's not V2. It is reduced. So it is 20 divided by 100 into the volume of the initial volume, which is equal to 600. Okay, so that is equal to 120 centimeter cube. Okay, and this is the reduction number. So the new volume is 600 minus 120, which is equal to 480 centimeter cube. Okay, understood this point, everyone? I guess this is clear. Now what are we going to do? We are going to calculate applying the Boyle's law. Why? Because the temperature is given as the constant quantity. So what are we going to do? P1 V1 equals to P2 V2. Putting the values in the equation simply. P1, it is given to us as 700, I guess. 700 into 600 is equal to 480 into P2. Transferring the values, 700 into 600 upon 480 is equal to P2. And when we solve for P2, we get the value as 875 millimeter of mercury. So this is the value of our second pressure. Okay. I hope this numerical is very much clear to you. It is very easy. The Boyle's law equations would be following this particular equation every time, and you will be given that the temperature is the constant quantity over here. Okay, we will be taking one or two more questions to understand this law in a perfect manner. So guys, if there is any confusion in this question or anything that you haven't understood, please do let me know. Moving on to the next question. The third question is, okay, this question would be a bit different. Okay, that means here we have to apply our mind a bit. Okay, that is not a direct question basically. Okay, so the capacity of one cylinder is 4 dmq. Okay, and other is 1 dmq. Now first of all, let us try to understand this question. We have been given two cylinders here. Okay, अभी तक हम लोगों ने जितने भी क्वेश्चंस देखे केवल एक कंटेनर होता था जिसका आपको डायरेक्टली वॉल्यूम दे रखा है, बट यहाँ यू आर हैविंग टू कंटेनर्स. तो वॉल्यूम के केस में we have to think a little bit more. Okay, now the next thing that is given is the pressure of first cylinder is equal to 560 mm of mercury. ठीक है, the cylinder 1, and second is 1000 mm of Hg. Again the two values are given, the pressure 1 and pressure 2. Okay, now both cylinders having CO2 are connected by tube fitted with a tap. So before solving the question, it's important to understand this question. Okay, तो सबसे पहले वी हैव बीन गिवन 2 सिलेंडर्स, ओके, जिसमें वन का कैपेसिटी है 4 डेसीमीटर क्यूब, ओके, एंड सेकंड का है 1 डेसीमीटर क्यूब. The pressure of first cylinder, it is 560 millimeter of mercury, और second का है 1000 millimeter of mercury. Now these both cylinders, okay, they are connected by a tube. Okay, now what we have to calculate, what would be the final pressure in either cylinder on opening the tap. Okay, so basically the question is asked that if we open the tap, what would be the final pressure. Okay, and also here the constant quantity which is given to us is temperature. तो ये तो फिक्स हो गया, बॉयल और लगेगा, लेकिन लगेगा कैसे? बिकॉज अगर आप सिंपली P1 P2 और V1 V2 से करेंगे, ये हो गया हमारा V1, ये V2, ये P1, ये P2. No, this is not going to be the same type that we solved the previous questions. Okay, now first of all let us try to understand this question. It is although a very simple question but a little tricky. तो सबसे पहले आपको बोला है these both cylinders they are connected by a tube. ओके, तो टोटल वॉल्यूम कितना हो जाएगा जैसे ही हम लोग टैप को ओपन करेंगे. ओके, सो टोटल वॉल्यूम ऑफ कार्बन डाइऑक्साइड आफ्टर ओपनिंग tap. Now that would be equal to 4 plus 1. That is 5 decimeter cube. ठीक है. Now this is the combined volume. Now for the first cylinder, now we will be calculating for first cylinder. Let's see what are the values given to us. हमें P1 दे रखा है 560, V1 is 4, so P1 it is 560 mm of mercury, V1 it is 4 decimeter cube. Okay, P2 we have to find out when V2 जो है final volume it is equal to what? 5 decimeter cube. This would be the calculation of pressure for cylinder first. Okay, so putting the values in the equation, since temperature is given as a constant quantity, P1 V1 is equal to P2 V2. तो लगाएंगे हम लोग values इस equation में. It's 560, I'll be writing down, into 4 is equal to P2 into 5. Okay, transferring the values, 560 into 4 upon 5. Solving it, we will be getting pressure 2 is equal to 448 millimeter of mercury. ये हो गया हमारा फर्स्ट सिलेंडर का प्रेशर 2. Okay, the final pressure of cylinder first. Similarly, we will be calculating it for second cylinder. Okay, so for second cylinder, it is P1 V1 equals to P2 V2 again. But here the values are, see, P1 it is 1 decimeter cube. So it's 1 decimeter cube, and V1 is 1000. Yeah, it was 1000 mm of Hg. Okay, then pressure 2 we have to calculate, and volume 2, no, I guess pressure was given to us. Volume, sorry, 5 dm cube. Okay, I have just written here, I have made a mistake here. So these are our values. Okay, so what are we going to do? We are again going to put it in the equation. P1 V1 is equal to P2 V2. So P1, it is 1000 for second cylinder into 1, which is volume, and P2, it is unknown, into volume 2 is 5. Calculating it, we get 200 millimeter of mercury. Okay, so this is the pressure 2, or I would say second pressure for the other cylinder. Now the question asks that what would be the final cylinder, okay, on opening the tap. So it would be the addition of first cylinder's final pressure and second cylinder's final pressure. So that would come out to be final pressure. It would be equal to what? The final pressure of container 1 plus final pressure of container 2. That is equal to 448 plus 200. So here we will be calculating it like this, which comes out to be 648 mm of Hg. All right. So this will be our whole solution, and this will be the answer to the question. Okay. All right. So I hope you guys understood this whole question. I hope you guys understood this law. Let's quickly revise what we studied in this law. So the Boyle's law, it gives us the relationship between pressure and volume when temperature is the constant quantity. Okay. So the equation of Boyle law, it is P1 V1 is equal to P2 V2, and here the temperature should be constant. We also did some of the questions, and I hope that you understood all the questions. If there is anything that you didn't understand, or if there is any problem, you can just ask to me. Also guys, for detailed study or to study a bit more, you guys can join our special classes. तो उसके लिए आपको क्या करना है? You just need to download the Unacademy Learner app, and you can select your class, select your grade, and you can go in for your classes. Okay, and just try it once. I'm sure you will be loving it. Okay, also guys, you can join our Telegram channel so that you can stay updated with all the ongoing offers which we are having at Unacademy, and you can also share the links of these classes with your friends. So to continue studying and to continue getting the updates, you can subscribe, and you can like and share the video if you really like this session. And ma'am, what if temperature is not constant? The law would not be applicable, beta. This law, this is the first condition. The temperature and the mass of the gas should be constant. Okay. Under this condition only, this law is applicable. All right. Okay. So with this, let's wrap up this session. I hope you enjoyed. We'll be meeting in the next class. Till then, you guys keep learning, keep studying, keep enjoying. Thank you. Bye-bye.